Hello and welcome to STEM Education. I am Syed Wahaj, and today we'll be learning physics for AS level or 12th year of this curriculum. So today we are going to start with our topics, and we are going to look at different kind of contents that we are going to provide you with. This is a book that has been compiled by STEM Education, and it contains a definition, notes, and practicals. It is also going to contain the different types of past papers, topic-wise, and an exhaustive study and exhaustive dealing with the different kind of topics and questions which are being asked in the A2 level examination. So let's get started with today's topic. The topic that we are going to deal with today is units and measurements. Units and measurements. That is the topic of today, measurements. That is the topic that we are going to start with today. So let's get started. I hope few students have joined. Okay, let's get started with this idea of units and measurements. So, first of all, the first question that we are going to deal with today is what do we measure? Because that is the first order of today that we have to understand different kinds of units and measurements that we are going to deal with. So we have different booklets over here with us, and let's open it for reference. This book is for the 12th, and this is the book, the student's book 1, and this is for the 12th grade, for the 12th year of this current curriculum. This is compiled by SAD, and let's refer to the first topic which we have in this book. See, it's the standard units in physics and estimation. That is the topic that we are going to deal with. That's what we are going to start. So let's get to the page. What is the number of the page? We are trying to get to the page. Okay. Physicists, these are different ideas that are related to physics. Yes, standard units in physics. That's what we are going to do. That is the topic for today, standard units in physics. Okay, so once we get started with this topic, we will have to have an understanding about measurements. So the idea, the word unit, it means one. Unit means one. Okay. And then in this topic, we have to deal with standard unit. Standard unit. What does this mean? What does the standard unit mean? The standard unit means that there are certain references that we have fixed for ourselves based on which we measure something. So when we are talking about units and standard units, we are basically getting ourselves concerned with the idea of measurement. The idea of measurement. Measurement. That is what we have got ourselves concerned with. So the first question that was also written on the board was, what do we measure? What do we measure, right? So we measure physical quantities. We measure physical quantities, right? Physical quantities, correct? What is a physical quantity? This is a circular definition to it. Whatever we measure is called a physical quantity, And a physical quantity is something that can be measured. Let's take an example of it. If somebody is asking you the question, how tall you are. Okay? How tall you are. This is the question. What is going to be your answer? What is the answer to this question? Answer to this question is, let's say, 6 feet. This is the answer to this question. Let me tell you that the thing that we have measured here is called length. Okay? Let's ask another question. Another question. Question number 2. How old you are? This is another question. What is the answer to that question? Let's say 24 years. Okay? 24 years. This is the answer to this question. Now, what have we measured here? We have measured time. So time and length, these two things are physical quantities. Physical quantities. Right? This thing, feet, it is a unit of length. Feet is a unit of length. Okay? 24 years. Years is a unit of time. Years a unit of time. Right? So when we are dealing with measurement, we have to ask this question to ourselves, what is it that we are measuring? And answer to that question is known as a physical quantity. Let's ask another question. How much do you love physics? How much do you love physics? Now, what is the answer to that question? I can answer that question very much. Very much. Can I really put a number to it? Can I really give it any value, any amount, any magnitude to this question that I love physics 7? Does that make any sense? It does not make any sense. We can say very much. We can say not that much. We can say, I don't love physics at all, but I can't really put a number to it, put a value to it. That is why love is not a physical quantity. It is not a physical quantity. Not a physical quantity. Why? Because we cannot really measure love. So when we are talking about physical quantities, we know that there are a lot of things that we can measure. There's force that we can measure, there's a pressure that we can measure, there's temperature that we can measure, number of people in a room, and amount of money that I have in my bank account, and a lot of things there are that we can measure. A lot of measurable things are out there. Now, the next question is, how do we measure a physical quantity? How do we measure a physical quantity? A physical quantity. How do we measure it? This is the question. And what is the process of measurement? What exactly is the step that we are going to take to measure something? So instead of giving it a lot of theoretical details, rather we should try to measure something. Let's measure a length. Let's measure length of a rod. Okay? Let's measure length of a given rod. Length of a given rod. Okay? Let's do it. So what do we do here? let's suppose we have this rod. We have this rod with us, and this is the length of this rod is unknown to us, and we want to measure the length of this rod. Okay, so what are we going to do about it? Let's do one thing. Let's take another rod of this length, another rod of this length. Okay, now how many rods are we having here? We are having two rods. One is a pink rod and another one is the blue rod. Let's give this blue rod a name. Let's call this blue rod as Jack, right? Let's call this one as rod. Okay, Jack. Okay, now let's keep another Jack here, then another Jack. Okay, another Jack. Okay, so 1, 2, 3, 4, 5, 6, and 7. So this pink rod is made up of 7 jacks. And let's call this blue rod as a standard length. A standard length. Okay? A standard length. So this standard length is repeated 7 times so as it gets completely accommodated inside the pink rod. Okay? Now we can say that length of the pink rod is equal to 7 jacks. Length of the pink rod equals 7 jacks, right? Now this is big. Why so? Because jack itself is a standard length. This is a standard length. Standard length, right? So this standard length is repeated 7 times so as to become equal to that of the pink rod. So what we do, we take a standard amount of a physical quantity, which is here length, and then we try to repeat that standard quantity a few times so that after repeating it in those many times, the whole of it becomes equal to the amount of quantity actually given to us. So what is the amount of quantity actually given to us? It's that of the pink rod. And what is the standard? The standard length is 1 jack. How many times it's repeated? It's repeated 7 times. Got it? So this thing, this jack, we call this jack, which is a standard length, we call this jack as unit. Okay? And the thing, and the amount of time, the number of time it gets repeated, 7, this is called magnitude. This is called magnitude, right? And then after combining the magnitude as well as unit, we call it the measured value. The measured value, right? So the measured value of any physical quantity consists of 2 things. First one is the unit, and second one is the magnitude. Unit is a standard amount of that quantity, and the magnitude is the number of times that standard quantity gets repeated so as to get completely consumed by the given amount of that physical quantity. That is the way we take measurements of anything, right? Again, let's move ahead. Let's further deal with the ideas of units. So let's take this jack again. Let's take this jack again, and let's make another standard quantity. Let's make it equal to this one. Okay. Okay. So what is it? What is it? There are two red rods, and these two red rods make up one jack. So this is what? This is one jack, right? And what is this one? Let's give this red rod another name. Let's call it crack. Okay? Excuse me. So this is one crack and this is one jack. So one jack is made up of two cracks. One jack equals two cracks. Two cracks, right? So one jack equals two cracks. So what we say that if we take another standard quantity, we also make it a standard. We also make it a standard. This is also a standard amount of length. Okay. Now we have this as a standard amount of length as well as this. We have two standard amounts of length. The name of one standard is called jack. The name of another standard is known as crack. And two cracks make up one jack. Now we can measure this pink rod using the red one as well. How do we do that? We can do this by 1 and 2, then 3, and then 4. Let's keep going. 5, 6, right? 7, 8, 9, 10, 11, 12, 13, and 14, right? So this pink rod is made up of 14 cracks. Got it? So we can write length of pink rod equals 7 jacks or 14 cracks. Got it? Either it is 7 jacks or 14 cracks. Now it is the same length, but what we are doing, we are changing the unit. Earlier it was jack and now it is crack. So which one is the bigger unit? This is the bigger unit. This is the bigger unit. Bigger unit. And the one with bigger unit has a smaller magnitude. Has a smaller magnitude. Right? Smaller magnitude. Right? So the one with bigger magnitude, has a small standard unit, has a smaller standard of length. So when we are talking about length, we can measure length using different units. We can measure length in meters, we can measure length in feet, we can measure length in inches, in light year, in parsec, in decimeter, in millimeter, in kilometer. There are n number of standard units which I use to measure the length. So we have understood that what is this. After that, the next thing we have to get ourselves aware with is called conversion factor. Conversion factor. conversion factor. So when we are using 2 units, we often have to convert 1 unit to the other unit. In the same case, we can write 1 jack equals 2 crack, right? 1 jack equals 2 cracks. Now what is jack? Jack is a standard unit, a standard quantity. And crack is also a standard unit or standard quantity. Yes, we have made it. When we are going to go into the scientific world, we are going to know that jacks and cracks are no units at all. But it was just for the sake of understanding the subject. So let's not get carried away by our suppositions. So 1 jack equals 2 cracks. Now what is this 2? What this 2 is called? This 2 is basically conversion factor. Conversion factor. Conversion factor. What this conversion factor does? It converts 1 unit to the other unit. Let's say if we are having 7 jacks, we can multiply 7 by 2 to get a number of cracks. Okay? Or if we are having 14 cracks, or we are having 14 cracks, we can divide 14 by 2. 14, we can divide it by 2. We get jacks. So what this 2 is doing over here? This 2 is used to convert 1 unit to another. If we want to convert jacks into cracks, we have to multiply by 7. And if we have to convert cracks into jacks, we have to divide by 2. So what this 2 is called? This 2 is called conversion units. This is called conversion factor. Conversion factor. And we need these conversion factors a lot in our study of science, in our study of physics, in our study of measurements, whenever we are measuring things in different physical quantities, not different physical quantities, the same physical quantity, if it is measured in different units, we need to have an idea about the conversion factor that we need to use in order to convert 1 unit to another unit. Now let's talk about some standard units. So let's start about some standard units of length. Some standard units of length. Okay, let's write them down. Let's write some standard units down. The first one is meter. We often use meter a lot. So meter is okay. So meter is a standard unit of length. Let's take second. It's centimeter. Centimeter. Okay. We call this simply m, and we call this cm. We have heard about it. Now, what is the conversion factor? How do we convert something which is in meter to centimeter, or when we convert centimeter into meter? So for that, we have to understand, we have to ask this question: how much is 1 meter? 1 meter equals 100 centimeters. Okay? If I have 1 meter, then it becomes equals to 100 centimeters. So 1 meter equals 100 centimeters. So what is this 100? This 100 known as conversion factor. Conversion factor. Okay? So wherever we are given meter, we can write 100 centimeters. So if we have 35 meters and we want to convert it into centimeters, what are we going to do? We are going to multiply this 35 by 100. Why? Because this 100 is the conversion factor. So when we multiply 35 by 100, we are going to get 3,500 centimeters. Okay? 3,500 centimeters. Got it? Again, if we are having 500 centimeters, 500 centimeters, we are going to have 500 divided by 100 meters. Okay, 500 divided by 100 meters. That means 5 meter. Okay, now we understand. So this one, Hala. I think Hala, can you hear me? Hala, you there?
Yes. Hello, sir. Sorry, I'm late.
Hello. How are you doing?
I'm good. How are you?
I'm also good. And Hamadan, are you also there? I cannot hear you. I cannot listen. Hamadan, can I listen to you? Is your mic working? Hamadan. Okay, you can also write it down. You can write it in the chats. If your mic is not working, or due to some reason you are not able to speak, you can write in the chats. Okay. Yeah, Hamadan. Okay. Now you're able to listen to me. Good. Okay, so let's keep on going, and let's keep working with what we were doing. So what we were actually trying to understand was that what is a conversion factor? How do we convert the quantity from one system of unit to another unit, right? So for that, we were actually discussing about conversion factors. So we say 1 meter equals 100 centimeter, right? So if we have to write 5 meter, we multiply 5 by 100, and then we can write centimeter. Or if we have 500 centimeter, we have to divide 500 by 100 to convert it into meter. Why? Because if we are converting bigger unit into the smaller unit, so meter is a bigger unit, meter is a bigger unit, meter is a bigger unit, and centimeter is a smaller unit, So what we do? We multiply, correct? So when we have to convert a bigger unit into a smaller unit, we multiply by the conversion factor. Let's write it down and let's remember it as well. What we have to do when we have to convert a bigger unit to smaller unit, then we multiply by the conversion factor. Multiply by the conversion factor, right? What do we do when we have to convert? We have to convert a smaller unit to bigger unit, then we divide by the conversion factor. Right? That is something that we have to understand. So if we have to convert a bigger unit to a smaller unit, like meters to centimeters, then we multiply by 100. And then we have to convert centimeter to meter. We have to divide by 100. Got it? If you want to write it down, go ahead. Be my guest, write it down, then we are going to move ahead. Okay, write it down. I'm giving you 2 minutes for that. Okay, now we have to deal with the other thing. The idea about prefixes. Prefixes. Okay. Now, what are the idea? What is the idea of a prefix? We often see that somewhere it's written centimeter, centimeter, kilo, meter, deca, meter, hectometer, hectometer. Also, we can say that it is milliliter, or megagram, centiliter. Okay, so in all these words, we say that centi, kilo, deca, hecto, milli, mega. These are the words which are known as prefixes. These words are known as prefixes. Why prefixes? Because they are fixed before the actual word. So centi comes before meter, milli comes before liter, mega comes before gram, centi comes before liter. So whenever we have a specific term that is always used before the given word, then it is considered as a prefix. And there must be some meaning to it. There must be some meaning of centi, there must be some meaning of deca, there must be some meaning of mega. So we have to understand what is it? What are the meaning of these terms? So let's get started. Let's write it down. So when I say deci, it means 1/10 or 10 raised to the power -1. So when I say that deci cucumber, so let's draw a cucumber here. We have this cucumber, and let's do one thing. Let's cut it down into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have this cucumber cut into 9 pieces. Let's write it down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How many pieces of cucumber we are having here? We are having 10 pieces of cucumber, and let's say all the pieces of cucumber are of equal sizes. Okay, then one piece of cucumber, like here, we have this one piece of cucumber, any piece, all the pieces are equal. This is called 1/10 of cucumber. So this is 1/10 of cucumber, or we can say that it is deci cucumber. Deci cucumber. Right? Cucumber. Got it? So deci cucumber means 1/10 of cucumber. Also, we can write in exponential form is 10 raised to power -1 cucumber. Got it? 1/10 of cucumber or 10 raised to power -1 cucumber. So that is called a deci cucumber. Got it? So whenever deci word is written somewhere, it means we are dividing something in 10 equal parts. Deci means dividing something in 10 equal parts. Got it? So when we say deci cucumber, it means we are dividing cucumber in 10 equal parts. Also, there is a word known as deca. Deca cucumber. We can say deca. The word deca means it is multiplied by 10. It is not divided by 10. It is multiplied by 10. It means we have 10 cucumbers. 10 cucumbers. Okay? What is 10 cucumbers? Deca cucumber. Deca cucumber is 10 cucumbers. Why? Because deca means 10. It simply means 10. It is not divided by 10, it is multiplied by 10. And what is deci? Deci is actually divided by 10. When we divide something into 10 pieces, it's called deci. When we multiply something to 10, when we increase the amount of something by 10, that is called deca. Okay? So this is the meaning of the prefixes. So let's write down certain prefixes and the meaning of them accordingly. So deci means 1 over 10 or 10 raised to power negative 1. Centi. Centi means 1 over 100 or 10 raised to power negative 2. Deci, centi, then we have milli. Milli refers to 1 over 1,000 or 10 raised to power negative 3. Deci, centi, milli. Then we have micro. Micro, it means 1 over million. How many zeros? 6 zeros. So from 3, we have gone to 6 zeros. It's 10 raised to power negative 6. Then nano, it means 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 raised to power negative 9. Got it? Pico. Pico. 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each time we are increasing it by 3. 10 raised to power negative 12. Femto. 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 10 raised to power negative 15. This is the meaning. We don't usually go up to femto at all, but this is what it is. Okay. Then we write some other prefixes. Let's write it in yellow. Yes, good color. So we write deca. It means simply 10. Hecto. Hecto means 100. And kilo. After that, we write kilo. Kilo means 1,000. Mega means 10 to the power 6. It's 10 to the power 3. It's 10 to the power 2. It's 10 to the power 1. Okay. Mega, then giga. Giga means 10 to the power 9. Okay. Giga is 10 to the power 9. Then it's peta. It's 10 to the power 12. And exa is 10 to the power 15. So these are the different values of prefixes that we have with us. And on the basis of these things, we can have the idea about conversion factors. We'll deal with the questions like that. I would suggest you go ahead and write them down. Write the values of prefixes. What does the prefixes stand for? I can give you a minute or two for that. Go ahead. write them down. Okay, I think you must have written down. Now let's do certain questions. Okay, the question is, if we have 100 mega grams, we have 100 megagram. How many kilogram? How many kilogram this is going to be? If we have 100 megagram, how many kilograms it is going to be? That is the question. Now let's try to answer that question. Since we don't know, fill in the blanks here, let's call it X. So let's say 100 megagrams is equal to X kilograms, and we have to find the value of X. What is X? Okay. So how do we try to find it out? Now, we can put the value of X. This is 100. We can write 100 as 10 raised to the power 2. And then we find out this word mega. So what does mega mean? We can go on the list and we can find out that whenever there is a mega, we can call mega equals 10 raised to the power 6. Okay? You can see here, when mega is written, mega means 10 raised to the power 6. Okay? So 100 can be written as 10 raised to the power 2, and mega can be written as 10 raised to the power 6 grams. And that is equal to, what is X? We don't know X, but we know kilo. And kilo is 10 raised to the power 3 grams. Okay? So we have 10 raised to the power 3 grams. Okay? Okay. Okay. Let's write it down. Okay. So we have to find out the value of X. What can we do? So we have grams to the both sides of equation. We can cancel it. And then we have 10 raised to the power 2, 10 raised to the power 6. It becomes 10 raised to the power 2 plus 6, which becomes 8. And then we can divide it by 10 raised to the power 3. This becomes 10 raised to the power 3 over 10 raised to the power 3 x. It gets cancelled, and x becomes equal to 10 raised to the power 8 minus 3, which is 10 raised to the power 5. So we have to find out the value of x, and here it is. X equals 10 raised to the power 5. That's what we have. That's what we are having. Okay? 10 raised to the power 5. So 100 megagrams. 100 megagrams equals x kilograms. And we have to find out the value of x. So 100 can be written as 10 raised to the power 2. Mega can be written as 10 raised to the power 6. Gram, let's write it as it is. X is written as it is. Kilo is written as 10 raised to the power 3. And then grams is written as it is. Since we are having grams to both sides of the equation, we can just cancel it out. And then we can divide the whole equation by 10 raised to the power 3. The 10 raised to the power 3 cancels each other to the right of the equation, and x remains to the right of equation. And to the left of equation, we have 10 to the power 8 and divided by 10 to the power 3. That gives us 10 to the power 8 minus 3. That is 10 raised to the power 5. We got the value of x. That could be a question that we can be asked in the examination. Okay, let's move ahead. Let's try to have answer to another question, that how many kilograms are there in a million milligram, right? This is the question. How many kilograms are there in a million milligrams? Now that is a question that we can answer very easily. This is the question which is exactly same as we had earlier. So let's write it down. How many kilograms? We don't know the answer to how many kilograms there are. Let's call it X. Let's say there are X kilograms equals a million milligram. A million milligram. Right? Got it. Now we have to find out the value of X. That's the whole point of this question. We have to find out how many kilograms are there in a million milligram. Right? Okay. So again, let's do the same thing. What does a kilo mean? A kilo means 10 raised to the power 3 grams into X, right? Equals, what does a million mean? A million is 1,000. Okay, that's what a million is. And what is milli? Milli is 10 raised to the power -3 grams. Okay, so we have X kilograms, X kilo. In place of kilo, we can write it 10 to the power 3, and then grams we can write as it is. A million milligram. A million, we can write a million as, we can write 6 zeros after 1, that's a million, and then milli. Milli stands for 10 raised to the power -3 grams. Okay? So what are we having here? We are having grams to the both sides. Let's cancel each other. Okay? Then we have to find the value of X. So let's divide it 10 raised to the power 3. Then here we can divide 10 raised to the power 3. This gets cancelled. The X remains the left of equation, and to the right, this can be written as 10 raised to the power 6 into 10 raised to the power -3 divided by 10 raised to the power 3. So 6 minus 3, it's 10 raised to the power 3 over 10 raised to the power 3, which means equals 1. So there is exactly 1 kilogram, which is equal to a million milligrams. Okay? So we can write a million milligram, a million milligram equals 1 kilogram. Right? That is a question that we might have to answer in examination. So that is the question, and that's the answer. Try to write it down in the notebook that you might as well be having. So write it down. I'm giving you a minute or two to write it down. Okay. It's 24, 6:24. I can take class off. 5 more minutes. Okay. Okay, I think this is something that we have done. Okay. Now we have to deal with the idea of system of units. System of units. Okay. System of units. That is something that we have to understand now. Now, what is a system? System is basically an idea that gives you an understanding about many things which combine together to make a system. System is not a single thing on its own. System is made up of certain things. So when I talk system of units, we are talking about a few things that make up some stuff. So before understanding system of units, we have to understand the idea of fundamental quantity. Fundamental quantities. The idea of fundamental quantities. Fundamental quantities. Okay. So let's say that I ask you, what is your age? What is your age? And you give me the answer, 16 years, right? Your age is 16 years. While answering this question, were you thinking about any other quantity other than your age, other than time? What we are talking about here? We are talking about time. The time for which you have lived. When you were born till now, how much time has passed? That was the question. That when you were born and up till now, how much time has passed? You would say 16 years. Now, while answering this question, answering the question of how much time you have lived, you did not actually think about anything other than time itself. You had no idea about any other physical quantity. If I'm going to ask you what is your height, you can tell me 6 feet, for example. So 6 feet, when you are telling me about 6 feet, you're not thinking about the time or how much do you weigh and how long you have lived, anything else. What is the temperature and what temperature you are currently? These kind of things, these kind of questions don't bother you while answering the question that how tall you are. So when we are actually talking about a physical quantity and we don't have to think about any other physical quantity, we just have to think about that physical quantity, then such kind of physical quantities are known as fundamental quantities. They are also known as independent quantities, also known as independent quantities. Independent, right? Why do we call it independent? We call them independent because while discussing about these quantities, we don't think about other quantities. Now, there are also certain quantities which are dependent on other quantities. Let's say they are dependent on the quantities. Dependent quantities, right? Dependent quantities, right? We also call them derived quantities. Derived quantities, right? So what are these derived quantities? Derived quantities are those quantities which depend on some other quantity. Let's say we ask you the question, how fast you are moving. How fast you are moving? Question. You are going in a car and I ask you how fast you are moving, right? Okay. So this question I'm asking two people. I'm asking two people, Mr. A and Mr. B. Okay. So Mr. A tells me that I go 50 kilometer in 1 hour, or in other words, 50 kilometer per hour. And what B says? B says I go 80 kilometers in 1 hour. Okay. So who goes faster? Tell me, who goes faster? A or B? It's 80 kilometers per hour. Okay, who goes faster? Tell me.
B.
Tell me, give me
B,
the
sir.
answer. Who goes faster? B, yes. Why? Because B goes 80 kilometers in 1 hour and A goes only 50 kilometers in 1 hour. But what kind of quantity we are talking about here? We are talking about speed. We are talking about the speed. The speed is a physical quantity, right? But this speed is actually dependent on two things. It is dependent upon the distance as well as time. So speed depends on the distance as well as it depends on the time. It gives 80 kilometers in 1 hour. So when we are talking about the speed, we are thinking about two other quantities. One of them is distance and another one is time. So speed is a dependent quantity or a derived quantity. Got it? So the value of speed is actually dependent upon the time, which is a different physical quantity, and the speed, which is a different physical quantity. You have to find out these two quantities, then you have to divide one quantity by another quantity, and then you are going to get the value of speed. So we can't really talk and think about speed independently without thinking about any other quantity. But when I'm asking about your age, you are not thinking about any other thing, correct? That is why time is a fundamental quantity. It does not depend on anything. Whereas speed is a dependent or a derived quantity because it depends on something else, in some other quantity. Got it? That is why we say that we have to have an idea about the fundamental quantities, how many fundamental quantities there are. So let me tell you, there are 7 fundamental quantities. Fundamental quantities, right? Fundamental physical quantities, right? 7 fundamental quantities. Other than that, all the quantities that we have are derived, are based on these fundamental quantities. So what are they? The 7 fundamental quantities that we know, based on which we find out all other quantities. The first one is length. Okay. The second one is time. The third one is mass. We have 3. The fourth one is amount of substance. Okay. Right. So amount of substance. What is amount of substance? When we are talking about how many students there are in a class, we don't think about time, we don't think about length, we don't think about anything else. We can just count them and say that there are 20 students in the class. So that means amount of substance is 20. So we have this fundamental quantity as amount of substance. Fifth, we have temperature. Temperature. Now, temperature is also a fundamental quantity. We don't have to think about any other thing. Sixth is called luminous intensity. Luminous intensity. So what is luminous intensity? It measures the amount of light. That is also a fundamental quantity. And then there is the 7th one. And this one is length, time, mass, amount of substance, temperature, luminous intensity, and electric current. Okay. So these are the 7 fundamental quantities. And if we are going to talk about any other quantity, like speed would be dependent on length and time. If we are going to talk about density, it is going to depend on mass and length. If we are going to talk about any other thing like force, it's also going to depend on length, mass, time somehow. Somehow the length, the time, the mass gets combined together and give us an other derived or dependent quantities. So just go ahead and write down the name of all these 7 fundamental quantities, because based on these 7 fundamental quantities, we are going to find out other different quantities. These are very significant. And then we have to find out the units which are required to measure all these fundamental quantities. Got it? Go ahead, write them down. Okay. Now, what are the different units? For example, length. Length has many units. It's meter, centimeter, feet, inch, right? But there was conference in Paris in the year 1960, And in that conference, they decided that all over the world, in the scientific field, people would use specific given units. And those units are known as SI units. System de International. That is the meaning. System de International. That is the meaning of SI unit. So SI, then the SI unit of length is meter. For time is second. For mass is kilograms. For the amount of substance, it is called mole. I'll discuss about mole later. Temperature is measured in Kelvin. Luminous intensity is measured in candela. This is the unit of luminous intensity, and electric current is measured in amperes. Ampere, right? So these are the different fundamental quantities and the SI units which are used to measure it. For example, when you are going to buy potato in the market, you are going to ask, give me 5 kgs of potato. So 5 kg, kg is the unit of mass. I'm asking you how much time is left for the class. You're going to answer in seconds. So second is the fundamental quantity. Is the unit of fundamental quantity of time. Okay, so there we have it. We have studied about the length, time, mass. We have studied about the physical quantities. So in this class, we have actually discussed about many things. We have discussed about what is it? We have discussed about units, measurements, what are physical quantities, and then we studied about different types of physical quantities. Okay, we studied about different types of physical quantities. Then we studied how do we measure things and what are the units and what is the meaning of standard units. Then we studied about the conversion factor. What is a conversion factor? Then after studying all the conversion factors, we studied about prefixes. After prefixes, we did some questions to understand how to use these prefixes to actually solve questions. Then we understand about system of units. For that system of units, we have to understand the fundamental quantities and the derived quantities. Then we try to note down how many fundamental quantities there are. So that was the class for today. Let's meet again in the next class, and we'll be covering up the remaining portion of this chapter in the next course. Sure. I think you can ask me any question, anything that you might be having doubt about in this chapter, and I'll be really happy to answer those questions for you. Go ahead. I'm waiting for you. If you have any question, ask me. Ask me from today's class. If you have any kind of doubt, anything that you would want to ask me, I'd appreciate it. No?
Sir, I've joined like really late. Can I just get the notes of these?
Yes, you can get the notes of these. I can send them over. I can give you this. I can give you the snapshot of the screen, and then you can go through it. Okay. And Hamadan, do you have any? Do you have any question? Have you understood the whole thing? Okay. Okay, so let's call it off, and I'll be sending you the screenshot of the whole screen, and we'll be done with it. Okay, bye bye.
Okay, sir. Okay, sir. Thank you so much. Allah Hafiz.
Okay, Allah.